Each square in a 3x3 grid of squares is colored red, white, blue, or green, so that every 2x2 square contains one square of each color. One such coloring is on the right below. How many different colorings are possible? So by WLOG, let's just let the middle thing be a white, like that. We're actually going to need some different grids for this problem, so I'm just going to draw a few grids. So let's just multiply by 4 at the end, and let's just let the middle thing be W. And by WLOG, still, let's just let, since we know that this one cannot be W, actually nothing more can be W, so then let's just let that one be blue. Okay, so then that's times 3. And then we can use WLOG again to say that this one is a red. So then that's times 2. So that's 24 times however many solutions we get with this. So obviously this has to be green. And then now let's do a little bit of casework. So since that's B, so case 1 is that this is an R. Case 2 is that that's a G. So the first case, that's an R. Obviously, this is going to have to be a G. And there's 2 options. This is RBR or BRB right there. Just be right back. So those are the 2 options. So it's going to be 24 times 2 plus, and then now this case. So obviously, this is going to be an R. And here, we know that there cannot be, so let's just look. We know that there has to be in G a 1 in these 2 squares, but we know that we cannot have a G in that square because we can't have a G twice in that 2x2. So this has to be a G. Similarly, this has to be an R. And then this has to be a blue. So then that's one case. So just 24 times 3, which is 72. This problem was pretty easy, and in my opinion, it's definitely misplaced. So the idea is just to first use WLOG and then use casework.